In this video, we're going to take a look at how to prove that corresponding parts of triangles are congruent. Before we look at a proof, we have this property that's going to help us with that process. So this property says that as long as I have congruent triangles, in other words, in this picture, if triangle ABC is congruent to triangle LMN, then all of their corresponding parts are also congruent. So what do we mean by corresponding parts? Well, if those triangles are congruent, then we know that all of the corresponding sides are also congruent, and also all of the corresponding angles are congruent. So really, again, if we have congruent triangles, we can say that all the matching sides are the same, and also all the matching angles are the same. So let's take a look at a proof that would involve that property of corresponding parts. So if we look at our goal here, what we're trying to prove, we see that we're trying to show that side AD and side AC are congruent. Well, we just saw that as long as I can prove that these two triangles here are congruent, then their matching parts are also the same. So that's our goal. We want to show that these two triangles are congruent using one of our properties, and then show that those corresponding parts are the same. So let's start with our givens. Let's mark the picture. We have angle D congruent to angle C. We have angle DAB congruent to angle CAB, that is up at vertex A. And then we also have this reflexive side AB that is shared in both triangles, so we can mark it congruent to itself. Once I have all these markings, we want to take a look at these two triangles and try and find the property that's going to help us prove that the triangles are congruent, which is going to lead into those corresponding parts being the same. If I look at what these triangles have in common, they have an angle, the red angles, they have another angle up here, and a side that is not in between the angles. So we're going to use AAS to prove that these triangles are congruent. So when I'm planning my flow chart, I need to make sure I have two angles and then a side that's not in between those angles to map out our flowchart logic. So we always start our flowchart by listing out the givens. Our first given was angle D congruent to angle C, and our second given was that angle DAB and angle CAB were also congruent. Those are our two angles out of the three items to get angle side. Now we also had that reflexive side, and so we show that that side is congruent to itself using the reflexive property. So now that I've listed out my two angles and my side, I'm now ready to show that those triangles are congruent by angle, side. Now I want to make a quick note here that the way I name these triangles is important. It doesn't matter how you name the first triangle as long as the second name matches the first. So if I name the first one triangle ADB, I have to name the other triangle ACB because A matches with A, D and C match, and then B matches with itself. Now, once I've proven the triangle is congruent, I then can prove that these corresponding parts, AD and AC, are also the same. One way to double check that you wrote that triangle congruency statement correctly is that if I look at where AD and AC are in the statement, they're the first two letters. They match not only in the picture, but also in the congruency statement. So now I'm ready to show that those corresponding parts of those congruent triangles are also congruent. And we do that by listing out those two corresponding parts as being congruent. And our reasoning is that property that we just looked at, that congruent triangles also have congruent parts. In this case, those corresponding sides being congruent. So that's how we prove that corresponding parts of triangles are also congruent.